Alright, so now we're off to start in Chapter 2. The first section that we have in Chapter 2 is Section 2.1, Perpendicularity. Our objective is to be able to recognize and apply the concepts of perpendicularity. In class, we'll be working on page 64 to 65, 2 to 14, all of them. Make sure if you have your book or open your book, take a look at those problems. Make sure we're going to be good with those tomorrow. Alright, so before we begin doing examples, we have a couple questions that we need to ask. First and foremost, what does it mean when two segments are perpendicular? And secondly, we have to make sure that we know what the symbol is for perpendicularity. So to you, when you see that two segments are perpendicular, what immediately comes to thought in your head? For me, when I think about perpendicularity of two segments, it's two segments who intersect to form right or 90-degree angles. Now, the symbol for perpendicularity actually looks like an upside-down capital T. Anytime we see two segments with that symbol in between, it means that they are perpendicular. And what will immediately stem from that will be that right angles are formed. So let's draw some examples of lines that are perpendicular. One example is very basic. It's that line AC is perpendicular to line DB. We know they're perpendicular because we see a right angle is formed at their intersection. Another example could be if we have a quadrilateral such as a rectangle. Here, we know that segment AB is going to be perpendicular to segment AC. Their intersection at A is where a right angle is formed. Next, I want you to read through this, and let's fill in the blanks together. So in algebra, the blank and blank are the perpendicular lines in the coordinate plane. The intersection of these lines can be called the coordinate 0, 0, or the blank. Take a minute, think about it, and let's fill in those blanks. Hopefully you got these right. In algebra, the x-axis and y-axis are the perpendicular lines in the coordinate plane. The intersection of the lines can be called the coordinate 0, 0, or the origin. And now we're going to get started with our first example. It's a proof example. And it's a fill-in-the-blank proof to get you guys started. Now, you'll see from this point on, there's no turning back with these proofs. We're going to be proof heavy for the rest of this semester. So, looking at our picture and our given statements, segment AB is perpendicular to segment BC, and segment AD is perpendicular to segment DC. We want to prove that angle B is congruent to angle D. Now, first thing that we want to do is state our givens, of course. So we have both givens. And we have two ways we can write that. We can either write them as two different lines or write them within one line. Next we have our first fill in the blank. Angle blank is a right angle. And we can write down definition of perpendicular. When lines are perpendicular, by definition, they form right angles. Next thing happens in our third step. Angle blank is a right angle, same as step 2. And for our last step, angle B is congruent to angle D, and fill in the blank for that. I'll give you a moment, and let's check our answer. Alright, so here we go. Our first blank, angle B is a right angle. Our second blank, angle D is a right angle. If you reverse those two, they're fine. Our next step, if two angles are right angles, then they are congruent. Something that we learned in Chapter 1. Alright, so let's get out of some of this proof business. Now, looking at our problem and our picture, how did I know this wasn't going to be a proof? Well, that's easy. When I look at my problem, I have given and I have find. Our trigger words for doing a two-column proof are either given in proof or given in conclusion. Anytime I have any other word, I know it's not going to be a two-column proof. So let's read this problem. Segment AB is perpendicular to segment BC, and angle ABD is 3 times as large as angle DBC. Find the measure of angle ABD. Well, the first thing I know I'm going to want to do is put a right angle mark where I have perpendicularity. Next, we have to think about angle ABD is 3 times as large as angle DBC. Now, here's the way I would do that. Think about which one would be larger, angle ABD, the first one, or angle DBC, the second one. Well, the larger one is going to be the first one. It's 3 times as large. So where we see that smaller angle, angle DBC, let's put an X where that angle is. Now, if that angle is X and angle ABD is 3 times as large, that angle would end up being 3X. Alright, now looking at my picture, I have a 3X, an X, and a 90-degree angle. What I'm going to do is solve for this algebraically. So by adding up my two angles, it's going to be set equal to my 90-degree angle because of perpendicularity. We're going to solve for X, and then we're going to plug it back in. So let's see what we got. Alright, so for our X value, we should have got X equals 22.5. 3X plus X is 90, so 4X equals 90, therefore X is 22.5. So what's our final solution going to be then? For our final answer, once we plug in 22.5 in for X and multiply it by 3, the measure of angle ABD is 67.5. Now, how would we go about checking that? Well, we'd want to compare 67.5, which is our 3X angle, with 22.5, our X angle. And we want to see if it's 3 times as large just by dividing them. If you have any questions, make sure you ask me about that tomorrow when we start going through this again. Alright, so what do you think? Are we going to have a proof or no proof? No proof. We have given and we have the word find. So we're given ABCD is a rectangle. We want to find the area of ABCD. Well, if it's a rectangle, what do we know is going to be in our corners? Right angles. The segments of a rectangle are going to be perpendicular. So let's start off by throwing in those right angles. Alright, next, as long as we know that perpendicularity, we see that we have horizontal lines combined with the vertical lines on our coordinate plane. So what I know here is from point D, I go straight up. From point A, I go straight to the right. Point B drops me straight down. And C brings me back over to the left. So what I know is if I'm going straight up to point A, which value is not going to change, my X or my Y? It should be your X. Now if I'm going from point B and moving my way to point A, which does not change, the X or the Y? The Y value. So let's write down the coordinate for point A. So the coordinate for point A is going to be at -4, 3. Now, we know this thing is a rectangle, so let's put some lengths on the side. What would be the length of side AD if it starts off down here at -4, -2, and goes up to -4, 3? What would be the vertical distance traveled? It traveled 5 units. Now, what's our horizontal distance? From -4, 3 to 7, 3. What do you think? It traveled 11 units. Now, some of you might be asking, how did I get that? What I noticed from my 5 units traveled, my X values didn't change, but my Y values went up by 5. That was the distance traveled. For my horizontal distance, I noticed that my Y values aren't going to be changing, but my X's sure did, from -4 to +7, which is a distance of 11. Now, area of a rectangle formula. Let's kind of go back in the brain and let's think about that. Area of a rectangle is base times height. We know we have a base, we know we have a height. For our base is going to be 11. Both the top or bottom can be considered our base. For our height is going to be 5 units. So when I multiply 11 times 5, that gives me 55 square units. How do we write square units? For square units, we're going to write units with a little 2, like such. If you have questions on this, please make sure you remember this one is going to be our area one. Alright, last but most certainly not least, if you're unable to prove something because the conclusion is just incorrect, in other words, it's not possible to prove what they're asking you to prove, you must write a paragraph explaining a counterexample. In other words, if you can't prove, it's not possible for you to prove what they're asking, you need to give an example and write it out in a paragraph form saying why this isn't able to be proven. What examples do you have that would show that this is actually incorrect? We'll be doing lots of examples where you're not going to be able to prove something. So if you're not really getting this, make sure that you and I have a conversation or talk with your group members, and we'll figure this stuff out.